Now, we will go to ion plating PVD. As mentioned earlier, ion plating is a method that essentially a combination of thermal evaporation and sputtering processes. Ion plating or IP is a PVD process that is sometimes called ion-assisted deposition, IAD, or ion vapor deposition, IVD, and is a version of vacuum deposition. What is ion plating? Well, ion plating is a technology originally developed in the 1950s in the USA, as part of NASA's space and aerospace technologies. It then spread around the world as a method to improve durability in cutting tools and molds. This technology uses heat along with energy from plasma to vaporize metal in a vacuum environment, combine it with a reactive gas to form a ceramic that is then used to bombard or coat a workpiece. In comparison with traditional wet plating, it is superior in abrasion resistance and adhesiveness. Ion plating is a vacuum coating process in which a portion of the coating species impinges on the substrate in ionic form. The process is a hybrid of the thermal evaporation process and sputtering, with the evaporation rate being maintained at a higher rate than the atoms that can be sputtered from the substrate. Some evaporant atoms pass through the plasma in atomic form, while some atoms collide with electrons from the substrate and become ions. They impinge on the substrate in ionic form, pick up electrons, and return to the atomic state, forming the coating. A variant process is reactive ion plating, in which the metallic constituent, for example, titanium, of the compound, titanium nitride, is evaporated into the reactive gas mixture of argon and nitrogen that is enhanced by the glow discharge, depositing a golden-colored titanium nitride coating on the substrate. Films of titanium nitride are applied to a wide range of tools such as bits, punches, dies, taps, and so forth, to improve tool life by 3 to 10 times. Principles of ion plating. Let's say, we take a look on arc ion plating. Arc ion plating is a technology whereby film-forming metal for coating is evaporated in a vacuum environment, and ionized by positive charges, from an arc discharge, attracting it to a workpiece to which negative charges have been applied, thereby forming a highly adhesive, hard ceramic thin film. The main metal for film deposition is titanium. Chromium, copper, aluminum etc. are also used. When the film-forming metal is titanium, by injecting a reactive gas such as nitrogen or acetylene to bond with the titanium, a ceramic film coating such as titanium nitride or titanium carbide nitride etc. will form, causing a particular coloring, gold, brown, gray, black etc. Ion plating process. In ion plating, the energy, flux, and mass of the bombarding species along with the ratio of bombarding particles to depositing particles are important processing variables. The depositing material may be vaporized either by evaporation, sputtering, or bias sputtering, arc vaporization, or by decomposition of a chemical vapor precursor, chemical vapor deposition, CVD. The energetic particles used for bombardment are usually ions of an inert or reactive gas, or, in some cases, ions of the condensing film material, or film ions. Ion plating can be done in a plasma environment, where ions for bombardment are extracted from the plasma, or it may be done in a vacuum environment, where ions for bombardment are formed in a separate ion gun. The latter ion plating configuration is often called ion beam assisted deposition, IBAD. By using a reactive gas, or vapor in the plasma, films of compound materials can be deposited. Ion plating is used to deposit hard coatings of compound materials on tools, adherent metal coatings, optical coatings with high densities, and conformal coatings on complex surfaces. Multiple film-forming metals, mainly titanium, called targets, are installed on the inner surface of the vacuum chamber. Nitrogen is injected as a process gas. Vacuum arc discharge is generated on the target surface. The titanium instantly melts and evaporates, ionizing in the plasma to become titanium ions. Nitrogen converts to nitrogen ions in the plasma. Nitrogen ions and titanium ions bond to become titanium nitride on the surface of the workpiece. The workpiece rotates and revolves, and titanium nitride is deposited upon it every time it passes in front of the target. Formation of a gold-colored ceramic film. This is an explanation about the film deposition process or coating, by arc ion plating. Features of ion plating. 1. Superior durability. By bonding vaporized metal with reactive gas, a hard, ceramic thin film can be formed, which is more abrasion resistant than wet plating and effectively improves the longevity of the product. 2. Highly adhesive. When discharged, the film-forming metal atoms ionize in plasma with high kinetic energy, thereby accelerating and colliding with the workpiece to form a highly adhesive thin film. 3. Hypoallergenic metal. If ion plating mainly uses titanium, so you don't need to worry about metal allergies. Titanium is biocompatible and rarely causes metal allergies, so it is often used in eyeglass frames, in repairing bones within the body, in screws for dental implants, surgical instruments, etc. So, okay, that's all for now. We will continue the online lecture on surface analysis and characterization on the next slide. Thank you very much for your attention. Assalamu alaikum. See you then. Bye.